Welcome to a video presentation of Chapter 8, Section 7 in the 8th grade textbook entitled Surface Area of Prisms and Cylinders. So it's a few weeks since we've looked at 3D geometry last. Before final exams and before reviews there, we were working with volume, and we were looking at the volume of the four primary three-dimensional shapes. Well, now we're still looking at the four primary three-dimensional shapes, but now we're switching to the surface area. So what is surface area? Surface area is the sum of the areas of the surfaces of a figure. The sum of the areas of all the surfaces of a figure. So what we're talking about there is it's just the area of all the different sides of a shape. That's what surface area is. So if you could find the area of each piece and add them together, that's one approach you could use to actually find the end result here when we're talking about surface area. That does tend to get a little bit complicated though, which is why we're going to learn some formulas to do that, which hopefully will make our lives a little bit easier rather than adding up the areas of all the pieces and saying this is my end result, which might result in a lot of calculations. Now, the formulas that you're going to see within are going to use some of the next two definitions in them. So we've got lateral face. Those are the parallelograms that connect the bases in a prism. And lateral surface in a cylinder, that's the curved surface connecting the circular bases. Again, lateral face, those are the parallelograms that connect the bases in a prism. And lateral surface in a cylinder, that's the curved surface connecting the circular bases. Alright, so let's go ahead and jump down here to our first couple examples. Obviously today, as you can see from the title, we're only talking about cylinders and prisms. So we'll keep that in mind here as we take a look at the examples. Now, as you remember from when we talked about volume, the reason that these two shapes are grouped together is because these two shapes share the same formula. Well, the exact same thing is true when we're talking about their surface area. So that would be a good place to start, is to start with that generic formula. Surface area formula for these two guys is 2b plus L. Now B is a returning friend. We've seen B before. B is the area of the base, the piece that the shape is resting on. Okay, we're used to that, or how it would rest normally. We can deal with that. What's new to us is L here. L is the lateral area. And remember, we defined those words lateral in the notes there, lateral face and lateral surface in the introduction, rather. So we're going to be bringing that in now here to talk about L. When we're talking about a prism, the lateral area is the base perimeter times the height. And as you can see, that means that this formula is going to be written a little bit differently down here when we get to our prism. Notice instead of writing L here, they wrote P times H, because that's what the lateral area is on a prism. It's the perimeter of the base times the height of that base. And when we're talking about cylinder, well, notice they've changed the formula a couple ways, which is what we're seeing here in part A. All right. Notice here, area of the base, that's been replaced with pi r squared because the base is a circle. We've seen that already when we talked about cylinders, when we dealt with volume. And the lateral area, all right, that has been replaced with 2 pi rh. Obviously, that would imply then that that is the 2 times the circumference of the circular piece there. Pi r being 2 pi r being the circumference formula times h, which is the height. Okay, so let's go ahead and take a look at these here. A here, we're going to plug numbers right into the formula. Again, really the only two things we need here really would be r and h. Of course, pi in our calculations, we can leave that as pi, or we can change it to 3.14, whatever the need be. But this 4 number here is going to be the radius. Remember, it's got to be halfway across the circular piece there. If it goes all the way across, that's the diameter, and you don't want that. And h is the height, how tall the guy is there, and that's that piece of information right there. All right, so we have r, we have h. Let's plug in some numbers. All right, we've got 2, which is part of the formula, times pi, which is 3.14, times the r number squared, 4 squared, plus 2, part of the formula, times pi, which is 3.14, times the r number, which is 4, times the height, which is 6, which is what you can see they're doing right here. Now it's a matter of simplifying. Now, what you see that's a little bit different than what I just said is that they still wrote pi as pi instead of changing it to 3.14. Right? You can change it to 3.14, and all you're going to do is skip this middle step here where it says 80 pi. Right? You want to make sure you do order of operations, so when you do that, which means you're going to have to grab this 4 squared first, then do all this multiplication on the left, then do all this multiplication on the right, and then add them together. Right? And when you do that, the end result is 251.2, and that's inches squared. Remember, this is an area here. It's a different type of area, but it's still the area. And if you remember, area was always given in units squared, so no surprise to us here that it's still units squared, in this case, inches squared. Remember, this answer here was just if we did not change pi into 3.14. And we could check to make sure this makes sense by changing pi into 3.14 and multiplying it by 80. And of course, yes, you would get 251.2, which is why this does make sense. This type of answer here is not necessarily needed unless they specifically ask for it. However, I think you are going to see that this year on the I-STEP testing and perhaps in some book questions as well. But that's all it is. It's the step before changing it to 3.14. All right, let's go ahead and go down and take a look at B there, our triangular prism. We know it's a triangular prism because it's got triangles as bases and the rectangles going all the way the rest of the round here. So let's plug some numbers into our formula. Now, the base here, remember the base would be how it stands, like if we think of a cereal box, how it would stand, the base would be the bottom piece. Well, when we're talking about a triangular prism, the triangles would have to be the bases. It can't be these rectangular pieces. All right, so we're going to have to find the area of this triangular piece here for B, and then we're going to need it again for P to find the perimeter around it, and H will still be the height, so we're not too worried about that. All right, so the area of that triangular piece. Well, remember, in a triangle, you've got to do half times the area of its base times its height, and remember the base and the height have to make the right angle, which is where this 8 and 3 come from. So this is half of 8 times 3. Well, half of 8 times 3, that's the same as 4 times 3, which is 12. And you can see that's written down there for you at the bottom. So that's where that piece of work came from. The 2 in front, well, that was just part of the formula. All right, we can see why it's 2 in front, though, because there's 2 triangular pieces, the front and the back. That's why the 2 comes in. Remember, it's really just the area of all the pieces adding up. The formula is just taking care of that for me by telling me there's 2 bases, which obviously it is. There's 2 triangular pieces. Okay, then I've got to find the perimeter of that triangular piece here. So the perimeter of this triangle. Well, we see this side is marked at 5. This side would also be 5, and we can see that marked here in the back. And the bottom is 8. So we've got 5 plus 8, or 10 plus 8, which is 18, which is what you can see right there. All right, the last number I need is h, which is the height of the entire guy. Now remember, as this is drawn right now, it's kind of like it's laying down. We don't want it laying down, all right, because the height would be what it is when it's standing on its base. So think about it if it was on the triangular piece standing up, like that. Right? Well, if it was on the triangular piece standing up, the height would then be this guy here. That's how tall the whole shape is, which is 10. And that's where the h comes from. And now it's just a matter of simplifying. 2 times 12 is 24. 18 times 10 is 180. 24 and 180 make 204. That's feet squared. Again, make sure you use order of operations there. Do your multiplications first before you go ahead and do that addition. All right, let's go ahead and take a look at number 2. In number 2, it says a cylinder has a diameter of 8 inches and a height of 3 inches. Explain whether tripling the height would have the same effect on the surface area as tripling the radius. Now, if you remember, we did questions like this earlier when it came to working with the volume. Right? And here they are again, working with the surface area. Even though it's a different formula, different concept, the approach is still exactly the same here. All right, you're still going to have to work the question out, try it with the tripled thing that they suggested, and see what actually happens. All right, and that's what they're doing here. All right, they told us that the diameter is 8, which is a good piece of information, but not directly helpful, because remember, what we really need here is the radius, which means though the radius would be 4/2, and the height is 3. So r is 4, height is 3. Well, if you remember from looking at the formula just a minute ago, that's all we really need, because that formula is 2 pi r squared plus 2 pi r h. Well, that's all we've got. All right. We've got an r after we derived it from messing around with the diameter a little bit, and we've got an h. We've got a height. That's all we need. So let's go ahead and start there with the original. So we plug in our numbers. 2 pi r squared plus 2 pi r h. We're going to change our r's into 4s and our h's into 3s. So it's 2 pi times 4 squared plus 2 pi times 4 times 3. And now it's a matter of simplifying. So as you can see, what the book did again here is they did this pi answer, which isn't again necessarily needed. You can just change pi into 3.14 and solve. You've got 4 squared, which is 16, times 2, which is 32. This is 32 pi. Over here you've got 4 times 3, which is 12, times 2, which is 24, 24 pies. And if you add those together, that's where you get your 56 pies from. And then you change it to 3.14 and do 56 times 3.14, and you get 175.8. All right, so now let's go back and make sure we know what we're doing here. We're supposed to explain whether tripling the height has the same effect as tripling the radius. So does tripling the radius and does tripling the height do the same thing? Notice they're not asking me like we did with volume, does tripling the number triple the answer? That's not what they're asking me here. What they're asking me is, does tripling the h number and tripling the r number do the exact same thing to the result? Well, let's bring our magnifier back up and let's take a peek. Let's start with tripling the height, which is what you see in the middle box there. So the height was 3, and if I triple it, now it's going to be 9. Well, remember, h only appears one time in that formula at the very end. So that's why they're saying 3h here. This would normally just be h, but we're supposed to triple it, which is why it says 3h. Of course, most of you are just going to go to writing in 9 right away, and that's fine. That's what they're showing you here on the second line. Okay, so we're solving that out. 4 squared first, which is 16, times the 2, which is 32. This is 32 pi. Over here, 9 and 4 is 36, times 2 is 72. That's 72 pies. If we add those pies together, we get 104 pi, or 104 times 3.14, which is 326.6. Okay, Now let's try it with the radius. So now I'm going to come over here and triple the radius. And what we want to see here is the answer should be 104 pi. All right, because remember they're asking us, did the same thing happen? So if I triple the r number now, that's going to change the formula in a couple spots. As you can see, they're showing this r being tripled here, which is why they've written 3r. And they're showing this r being tripled here, which is why they've written 3r. So since the r number was 4, when I triple it now it's going to say 12. So this is 2 times pi times 12 squared, and 2 times pi times 12 times 3. Well, we're simplifying here. 12 squared is 144, times the 2 is 288, that's 288 pi. Over here, 12 times 3 is 36, times 2 is 72, that's 72 pies. Add those together, you get 360 pies, or the same thing as 1130.4. So we got 1130.4 there, and back over there we got 326.6. So no to answer the question. The same thing does not happen when I triple the radius and when I triple the height. We get different answers there. Okay, let's go ahead and keep going and taking a look at example 3 here. Number 3 says that a cylindrical soup can is 7.6 centimeters in diameter and 11.2 centimeters tall. What is the area of the label that covers the side of the can? So there's a couple different approaches here to this question. What you can do, if you want, is you can find the total surface area of the soup can and then take off the area of the two circles, the top and the bottom of the can. Because, of course, the label doesn't go on the top and the bottom of the can. The label just goes around the can. Now, what they're doing here instead is they're looking at that formula for a cylinder, and in case you've forgotten, that formula says 2 pi r squared plus 2 pi rh. And what they're saying is that this part of the formula here, 2 pi r squared, well, that actually is the area of the top and the bottom, the circular pieces put together. That's why it says 2 pi r squared. Pi r squared is the area of the circle. There's two circles, the top and the bottom. So instead of me working the whole formula out and taking some pieces out, let's instead just get rid of this from the get-go and just find 2 pi rh, which must somehow be the formula for finding the area of the actual can piece. And that's what they're going to do here. And that's quite fine. So we're going to take 2 pi rh and plug in our numbers. Now, what we don't want to do is use 7.6, because 7.6 is the diameter. And I don't want the diameter, I want the radius. So of course you want to start off and you want to cut this in half to get yourself back to the radius. Well, when I cut this guy in half, as you can see from working in the question here, that's why it says 3.8. And this height, 11.2 centimeters, that's fine. So, plug in our numbers. 2 times pi, which is eventually going to change into 3.14, times the r number, which is 3.8, times the h number, which is 11.2. Now, as you can see in the answer line there, they're showing you the answer with and without pi. All right, what they've done here first is they've done the 3.8 times the 11.2 times the 2, which is they got 85.12, but conjoined it with pi because they haven't done the 3.14 bit yet. So 85.12 pi would be an acceptable answer. And then what you would do is you would change pi into 3.14 and do 85.12 times 3.14, which is 267.3. So the label is going to cover 267.3 centimeters, and that should really say centimeters squared, not centimeters cubed. Okay, so let's go ahead and take a look at the concluding example here, the check it out example 2 pi r squared plus 2 pi rh is the formula I'm going to need here, because we're finding the surface area of a rather stubby cylinder, but a cylinder no less. If we take a look at that cylinder, we see a radius of 15 and a height of 3. So wherever I see r, I'm going to change it into 15. Wherever I see h, I'm going to change it into 3. So let's go ahead and do that, and we'll write our answer with and without pi, just so we can see that one more time here. So this is 2 times pi times the r number squared, 15 squared, plus 2 times pi times the r number, which is 15, times the h number, which is 3. All right, so we'll use the order of operations to solve here. That would be essential. 15 squared, 15 times 15 is 225. And then times the 2 in front, that's going to be 450, isn't 450 pi. And then over here, 15 times 3 is 45, times 2 is 90, so that's 90 pi's. And if we add that together, that's 540 pi. So there's your answer with pi. Now, they want you to simplify it by changing pi to 3.14 and multiplying, but you already know that answer because it's on the screen, 1695.6, and that's centimeters squared. So the area of the cylinder is 1,695 and 6/10 centimeters squared.